Hi guys, let me take you through this example again, where we're trying to build a confidence interval for the true mean date in our penny container. We took in class a simple random sample of size 30, and the mean we got was 1988.4. So the randomness condition is met. Our sample can be considered a simple random sample. A simple random sample from our population. The independence condition is met because 10 times our sample size is 300. That's less than or equal to the 518, the size of the population. That's the number of pennies in the penny container. So we can treat our 30 observations as being independent of one another. The normality condition is also satisfied. It doesn't matter that our population distribution is skewed because our sample size is 30. That is greater than or equal to 30, so the central limit theorem. The central limit theorem applies. In other words, we can treat our sample means as not normally distributed, but it would be better had I written approximately normally distributed. More is better. I would rather have samples of 40 or 50. This is a limit because in the limit, as your sample size grows, the normal approximation for means, notwithstanding the shape of the population, the distribution of the means, its shape appears more and more normally distributed. So what I want to build is not a 56% confidence interval. Let's instead build an 80% confidence interval for the true mean date in our penny box. So for practical purposes, I'm interested in the central 80% of the sampling distribution. So essentially what we are doing is we're, if you will, ignoring 20% of the sampling distribution. We're ignoring that most extreme amount of variability on the lower 10 and upper 10% of this distribution. So what that means is we have to disregard that lower and upper 10%. So that's here and up here. So the critical value then that we seek, so again, what this critical value represents is how many standard deviations above and below the sample mean I'm going to use in order to build the boundaries for our confidence interval. So again, let me repeat that. Z star is the critical value. It tells me how many standard deviations above and below the sample mean I want to go in order to find an upper and a lower boundary. I need to find this z-score right here. That z-score and the opposite of that z-score, those will bound the middle 80% of the sampling distribution. But to do this, you have to determine the percentile at which this z-score sits. So that percentile includes all of this area at or below that particular score. So to build 80% confidence intervals, I actually am at the 90th percentile. That is the 90th percentile. I have cut off the lower 10% and the upper 10% of the sampling distribution to find the middle 80%. But the percentile includes all of the area at or below this z-score. That's the lower 90% of the sampling distribution. That's the 90th percentile. So this is an example of where you would want to use your inverse norm command. So second variable's inverse norm, the area you would want to put in is 0.9. So that gives me 1.28. So what that tells me is here, negative 1.28 and positive 1.28, those are the z-scores that bound the 80% in the middle of the sampling distribution. So to find my lower and upper boundaries for my confidence interval, I want to add 1.28 standard deviations to my sample mean, and I want to subtract 1.28 standard deviations to my sample mean. So here is where how we'll build the confidence interval. Our estimate for the truth is our sample mean from our sample of 1988.4. So to calculate my margin of error, there are two components for the margin of error. This entire expression right here, in total, this is the margin of error. So that margin of error is calculated by using 1.28 standard deviations. This expression right here is the standard deviation of the sampling distribution. The standard deviation of the sampling distribution, we do know the population standard deviation is 11.9. Our sample size is 30. So I want to divide that by the square root of 30. So 11.9 divided by the square root of 30, that will give us the standard deviation of the sampling distribution. That's about 2.17. So the reason that I'm writing it out this way, I want you to realize that the margin of error, what we're going to add and subtract to our estimate to build our upper and lower boundary for the confidence interval, this is the standard deviation of the sampling distribution. We are going to take 1.28 of those. We're going to multiply that by 1.28. That will give us our margin of error. There we go. So we have a margin of error of about 2.78. So that 2.78, that is 1.28 of these standard deviations. 1.28 times this. That's how many 1.28 standard deviations I'm going to add and subtract to my sample mean in order to build the upper and the lower boundary of this confidence interval. So let me do it on my calculator here. So 1988.4, 2.78. So I'm going to subtract the 2.78 from it. I'm going to take the 1988.4 and I'm going to add the 2.78 to it. This is the lower and the upper boundary for my 80% confidence interval. So the way that we would write about this then, in context, we can be 80% confident that the true population mean penny date, the real population parameter, the real population mean penny date is between 1985.62